This is section 6.1, and this section is about ratios. A ratio is a comparison of two quantities that have the same units. And we can write a ratio in three different ways. We can write A to B using the word to. We can use a colon to represent A to B, or we can use a fraction to represent A to B. B cannot be 0, and anytime we have a denominator of 0, that would make your fraction undefined. In an algebra class, there are 15 women and 17 men. Write the ratio of women to men. Now, order counts, so we're going to use women in the numerator, 15, and men in the denominator, 17. So the ratio is 15 to 17. Write the ratio of men to women. This time, 17 men are in the numerator, 15 women are in the denominator. Write the ratio of women to the total number of people in the class. So the total number of people is the number of women plus the number of men, and 15 plus 17 is 32. So the ratio of women is 15 in the numerator. The total people in the class is 32 in the denominator. We're going to write ratios in lowest terms, and we have 15 feet to 10 feet. And so I start by writing it as a fraction, and then I recognize the units are the same, so the units will cancel. We can divide out a common factor of 5, and my ratio is going to be 3 to 2. So when we write ratios, we're going to have a whole number in the numerator, a whole number in the denominator, and we don't need any labels because the labels cancel. The units are the same. So whole number, no labels. $20 to $10, our dollars cancel. 20 divided by 10 is 2. But a ratio is a comparison of two quantities, so we couldn't just write 2. We have to write 2 to 1. Which expression represents the ratio 4 to 1? Well, clearly 4 to 1 is the choice with 4 in the numerator. If we have mixed numbers and decimal numbers, when we write a ratio, we have to change those to whole numbers. So if we want the ratio of the length of a rectangular picture frame that's 7.5 inches and the width is 6.25 inches, the ratio of length to width, we have 7.5 inches to 6.25 inches. So first of all, inches will cancel, and we have 7.5 to 6.25. So you could do this in your calculator and use the decimal to fraction button. If I'm doing this by hand, I will recognize that if I multiply this fraction by 100 over 100, that gives me 750 over 625. And then I can divide both numerator and denominator by 125 to reduce this fraction. And my final answer will be 6 to 5. Ling walked 2 1/4 miles Monday, 3.5 miles on Tuesday. Again, the miles will cancel. The ratio of miles walked Monday to Tuesday is going to be 2 1/4 to 3 1/2. So we have to do 2 1/4 divided by 3 1/2. Change these to improper fractions. That'll be 9/4 divided by 7/2. And then remember, we keep the first fraction, change to multiplication, and we take the reciprocal of the divisor. And here we can reduce this fraction by dividing out a common factor of 2, and I get 9 to 14 as my reduced fraction. And an application problem. After the tragedy of Hurricane Katrina, New Orleans showed signs of recovery as more people moved back into the city. 3 years after the storm, New Orleans had the fastest growth rate of any city in the United States. During a 1-year period, the population went from 210 to 239,000. Write a ratio expressing the increase in population to the original population. So to get the increase, we're going to subtract, and there's a 29,000 person increase. The original population is 210,000. So we're going to do 29,000 divided by 210,000. And remember, we can divide numerator and denominator by 1,000. Chopping those zeros off the end, we get 29 to 210. And here's some problems for you to try.